Hey guys, today we are getting into special pairs of angles. We are going to be hitting some more terms and different types of angles pretty quickly. You will want a straight edge to draw in these angles. So let's start off with some of these new terms. So the first two kind of go together. The first one we have is complementary angles, and it is two angles whose measures add up to 90 degrees. The second one says supplementary angles, two angles whose measures add up to 180 degrees. So complementary angles and supplementary angles are two terms that are often very confused by students. And so one way that helps me to remember is I think of compliments. When someone gives you a compliment, it's always the right thing to do. So that helps me to think of right angle 90 degrees, whereas supplementary is 180. I've heard of alphabetical order as a way to remember. C comes before S, 90 smaller than 180 when you're counting. So that's another thing to help you remember. Use as many of those little devices that you can so that you can get those down and ace this test coming up. So complementary angles. Let's draw in, let's say I have an angle here. Again, use your straight edge of 43 degrees. If I choose 43 degrees, then its complement is whatever will add up to 90. So the complement of 43 would be 47 degrees. 43 plus 47 would give me 90. If I start with that 43 degree angle again down here though with a supplementary angle, then its supplement would be whatever would make it add up to 180. So 180 minus 43 would be 137 degrees. Adjacent angles are two angles that share a common vertex and a side but have no common interior points. So we've seen adjacent angles before. So if I have an angle like this, there's one angle, and then I have another angle here. They're sharing a side and a vertex. So here's my other angle. Those are two adjacent angles. A linear pair is a special kind of adjacent angle. So linear pair is two adjacent angles whose non-common sides are opposite rays. Think back to day one in here. Opposite rays form that straight line. So here's one of my angles. And then if I have another angle, these two angles form a linear pair. You should notice that then these two angles are also going to be supplementary because they will add up to 180. That's what that straight angle would make, those opposite rays. All right, another kind of angle or angle pair are vertical angles. And this says two angles whose sides form two pairs of opposite rays. So if I draw in, I'm going to draw it like this. Vertical angles would be right here and right here. Those two angles are vertical angles. So their sides form two pairs of opposite rays. They form those straight lines. They're across from each other. I think vertical angles, they meet at the vertex, that point right there. Okay. So, let's look at this picture here. So in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So, complementary angles. Let's see. Complementary means they add up to 90 degrees. So I'm looking for two angles that add up to 90 degrees. And I see 50 degrees here, and I see 40 degrees here. So when I name those, I would say angle DEF and angle AEF. B, C. All right, then I need a pair of supplementary angles. So I'm looking for two angles that add up to 180. So I have this angle right here that's 140 degrees, and this angle right here that's 40 degrees. So angle GEF and angle ABC are supplementary angles. The last one is adjacent angles. So adjacent angles are two angles that are next to each other. So in this case, we have angle DEF and angle GEF. Those are two angles that are next to each other, so they are adjacent angles. Okay, then question 2 says, given that angle 1 is a complement of angle 2, and the measure of angle 1 is 73 degrees, find the measure of angle 2. Okay, well we know that complement means two angles that add up to 90 degrees, so we can do 90 minus 73, and we get the measure of angle 2 equals 17 degrees. Then we have, given that angle 3 is a supplement of angle 4, and the measure of angle 4 is 37 degrees, find the measure of angle 3. Okay, well we know that supplement means adds up to 180, so we do 180 minus 37, and we get the measure of angle 3 equals 143 degrees. Okay, question 4 says, identify a linear pair and a pair of vertical angles in the figure. Okay, there's more than one right answer here with the linear pair, but if I think back, or if I look back to page 1, linear pair was two angles, two adjacent angles whose non-common sides formed opposite rays, formed a straight angle. So I'm looking for two angles that touch each other and whose non-common sides form that straight line. So a linear pair would be angle 1 and angle 2. Another linear pair could be angle 2 and angle 3. Vertical angles. So vertical angles here, we only have one option, and that would be angle 1 again with angle 3. So angle 1 and angle 3. They're across from each other. They're only touching at the vertex, and their sides form opposite rays. Okay, then this says two angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. If this doesn't make sense right away, draw a picture. So immediately I see linear pair. So I'm going to draw a picture of a linear pair. And I know that a linear pair is two angles whose sides form that straight line. It says the measure of one angle is 4 times the measure of the other. Well, when I don't know something, I usually give it a variable. So I'm going to say this is x. I don't know that. This is 4 times that angle, or 4x. We know that linear pairs add up to 180 degrees. So I can take these two angles and use my angle addition postulate and say 4x plus x equals 180. So that's 4x plus 1x, or 5x, equals 180. Divide by 5 on both sides. So when I divide by 5, I get that x is 36. So that's the measure of one of the angles. So 36 degrees is one of your answers. And then we need to do 4x, or 4 times 36. And we get 144 degrees for our other angle measure. Okay, the last piece here is talking about diagrams. And so we've talked a lot about how you can't just assume the things that you see in the diagram, even if it looks like it might be true. So if you look at the top picture, it says there's some things that you can conclude and some you can't. So here are some things that we do know. All of the points shown lie in the same plane. So think back, that is coplanar. All of the points lie in the same plane. So all points shown are coplanar. Points A, B, and C are collinear. They all lie in the same line. We see that AC, ray BD, and ray BE all intersect at point B. Then we see that angle DBE and angle EBC are adjacent angles. So DBE, if you want to trace that, and EBC are adjacent angles. And angle ABC is a straight angle. You trace that one as well, ABC. Point E lies in the interior of angle DBC. Okay, so all of those things are true. We can see that from our picture. But here's some things you might be tempted to say that we can't actually conclude. So we don't actually know that AB is congruent to BC. To show that AB is congruent to BC, we would have to put those tick marks in there to show they're the same distance. We also don't know that angle DBE is congruent to angle EBC. To show that, we would have to have those arc marks. We also don't know, even though it looks like it might be, that ABD is a right angle. We would have to put that little box in the corner. So that's how we would show those things, but if they're not there, we can't assume that. All right, as always, if you have questions, come in and see me, and I will see you in class.